Okay, so this is your first set of notes, and we're going to start with just Quadratic Basics. So you should have received a booklet that looks like this. This is the front of it. It says name over here, and the back looks like this. It's probably a different color than mine, but that's okay. So the expectation here is that you're going to fill out the notes where I fill them out. So your notes should match my notes. So we'll start with we're transitioning from transforming functions to just focusing on quadratics for the next couple weeks. So we're going to start with some basics. We're going to talk about how the equations can look in different forms, and then we're going to talk about how to solve them in different ways. So first thing is, let's just review some basics. You may remember this stuff from Algebra 1, and we may have used some of this language in class already, but this is just a quick reminder. So we do want you to put your name on it, just in case it falls out of your binder or gets left behind. So please put your name on it. All right, and we're going to start up here. So here's our quadratic function. We're going to label a handful of important pieces of information on here. The first one is right here, and this is the y-intercept. So that's our y-intercept. And again, I know some of this vocabulary is not new, but this is just kind of a quick review so we can all be on the same page. So in addition to the y-intercept, we obviously also have x-intercepts. So here's my x-intercept, and that's going to be right here. And my other x-intercept we'll put here, and we'll draw an arrow to there. So our x-intercepts are where it's crossing the x-axis. And right here, we've talked about this before, this is our vertex. And we're going to talk a little bit more about it also being, in this case, a minimum. So it's the minimum point. And the reason it's a minimum point is because it's opening up and your a value is positive. Okay, so this is what it could look like. This is when our a value is positive. Here's my vertex. Remember, we're going to write our vertex, and actually, you'll see this on the back as well. We're going to write it h, comma, k. Okay, so next, we're going to scoot down here. And now, you see we have another quadratic, except this time it's been reflected over the x-axis. So, a couple of important pieces of information. Because you can see right away that it's been reflected. So, this is reflected, which means a is negative. That's why it's facing down. And because a is negative, this point right here that's our vertex, and again we're going to name it h, comma, k. Our vertex in this case is a maximum. So we have that, and then we've got our y-intercept right here. And then we've got our x-intercepts. All right, so I'm going to draw an arrow to that one. Okay, so that is kind of an introduction to just some vocabulary when we're talking about the quadratic itself. Okay, we're going to flip it over to the back, and we're going to talk about these different forms. And again, I know some of this is review, you saw it in Algebra 1, but we're going to be diving a little deeper into some of these pieces. So we've got our standard form. We're going to be using a lot of that later with quadratic formula, and we're going to use it in the beginning to solve by factoring. So we'll talk more about that in the next video. We've got vertex form, which we also have called transformation form. That's what we were calling it before, but now we're going to actually call it the vertex form. And the reason we can call it that is because you can see our HK here. That is our vertex. So if you're just given an equation in vertex form without even seeing it graphed, you can automatically name the vertex. Okay, and then further down we have intercept form, which sometimes we also call factored form. And we'll use those interchangeably because this is factored, which is actually in a couple videos as well. So those are our three forms. And one of the things you're going to do on the next document is you're going to look at an equation and name the type of form it is. So you'll refer back to this page. Okay, so now we can open it up. So I've opened up the inside of the booklet, and now we're solving graphically. So this is kind of similar to what we were doing when we were solving nonlinear functions. Systems of nonlinear functions, but that had two different equations. When we solve quadratics graphically, there's going to be one equation and there's only going to be one graph on our x and y axis. So we're going to show some examples here. Two real solutions means that it has two x-intercepts. So I'm just going to draw a quick one here. Yours can look like anything you want as long as it's crossing in two spots. So those are our two x-intercepts. We will also refer to those as solutions. Sometimes we will also call those roots. So we use those terms a lot interchangeably. So the next one, we have one real solution, and we call this a double root, which means it has one x-intercept. So that typically means that it's sitting on the x-axis. It could also be upside down and be touching the x-axis like that. So we call this a double root, and we'll talk more about that later, is because that specific factor is being squared. All right, so then our last one is there are no x-intercepts, so there's no real solutions. So that means it's not touching the x-axis at all. So we could be floating above it, or if you wanted, we could be floating below it. So there are no real solutions for those. So that's if we solved it graphically. What we're going to really focus on, though, is solving algebraically. So I'm going to turn this a little bit this way. All right, so solving algebraically. We are going to be solving by factoring. That's actually what the first assessment this quarter is going to be on. And then we are going to do it with the quadratic formula. Both of these ways are algebraic. And if you notice on the bottom, there's also using square roots and completing the square. We're really not going to do this that much in class. You may see it in an A-level extension, but the focus really is these other two methods. So we're going to solve by factoring. All right, so in a couple videos, you're going to focus on this a lot, talk about writing things in standard form, talk about factoring out the GCF, and then you're going to factor the rest of the equation, and then you're going to use it to solve. You don't really need to worry about all that right now. We're going to go to Doc 1, and we're going to use the information from these notes to work on Doc 1. So Doc 1 looks like this. And we're going to do number 1 together because I want to show you where I'm getting this information from. And I want to highlight a couple things about some new notation that you might see here. So complete the following. So our vertex, we see that right here. It's already labeled with a coordinate. A vertex is always a coordinate. It's always xy, or in this case, we can think about it as hk. All right, and we can see that since it's opening down, that this is actually a max point. This is the highest point on that whole quadratic. Our number of solutions is going to be the number of times it's crossing the x-axis. There are 2 of those. And then I ask for equals, and you can see these braces here. Sometimes I call them fancy brackets. When we do this, and this is different than solving systems of nonlinear equations, we don't want an x and y coordinate. We only want the x coordinate. That's it. We don't want the whole x and y. We just want this x value and this x value. And typically we put them in numerical order. So x equals, and we have these braces here, -2, comma, and I'm going to put the 4. So I want to reiterate this again. This, when it's in these fancy brackets or these braces, this is not a coordinate. This is one x value, and this is a different x value. So you can see that the coordinate here was -2, and the coordinate here was 4. So you're going to complete the rest of this paper, front and back, and then you are going to get it checked by your teacher.